Hey guys, my name is Owen White, and I'm going to be talking to y'all on Newton's third law. I'm screen recording on my iPad. Hopefully that's going to work. And then I'm going to send that and we'll mesh them together. Newton's third law by Owen White, Kevin Avila, Andrew Norris, and Corey Moore. Members, Corey Moore and Owen White. This is the second slide. I'm going to be talking through the first sections so we can each get credit. Introduction. Newton's third law of motion states that for every action there is an equal and opposite reaction. This means that whenever one subject or object exerts a force on the second object, the second object exerts an equal force in the opposite direction on the first object. These forces always occur in pairs and act on different objects. For example, when you push up against a wall, the wall pushes back and with an equal force. A rocket launches because the engines push the gases downward, which is the action, and the gases push the rocket upward, which is the reaction. Section 2, experimental process / impact. The original experimental process described. To investigate Newton's third law in a novel way, we designed an experiment using low friction carts and motion sensors on a track, along with custom-built spring-loaded impact mechanisms. Instead of just observing the basic action / reaction with hand-applied forces, we generated an apparatus that allowed one cart to push another using compressed spring while both were tracked simultaneously using digital motion sensors. These carts were outfitted with force sensors to record the magnitude and duration of forces during the interaction, offering a high-resolution look at how the equal and opposite reactions play out in real time. Another example would be these marbles, as you can see, right here in the bottom left corner. Each marble gets the energy exerted through, and therefore on each side there is an equal and opposite reaction. Section 3, experimental process and the impact. The modern experimental process described. In modern physics and engineering, Newton's third law, for every action there is an equal and opposite reaction, is tested using advanced tools such as force sensors and motion tracking systems. High precision instruments measure forces in real time, making it easier to verify the quantity of everything. Simulations and modeling software, programs like analysis or Python-based physics engines help simulate complex systems where action and reaction forces apply. This also is applicable in high-speed cameras, which makes sense. These allow scientists to observe fast interactions with the naked eye that would normally miss, confirming the simultaneous nature of action-reaction pairs. And then our last example is micro and nanoscale experiments. Newton's third law is studied on atomic levels using atomic force and microscopes and other quantum scale tools. Section 4, motivation and development. When a swimmer pushes against the wall of a pool with 120 newtons of force, what force does the wall exert back on the swimmer? Relevance of question to the topic explained. For every action, there is an equal and opposite reaction. This question directly relates to Newton's third law of motion, which is about two objects, forces interacting with each other. In this case, the swimmer and the wall of the pool are interacting bodies. The action, the swimmer applies force on the wall, and the reaction is the wall applies an equal amount of force to the swimmer. Go to section 5. Demonstration / solving. If a swimmer pushes against a pool with 120 newtons of force, how much force does the wall push back with? This question helps us see Newton's third law in action. 5.1, the relevant chart and graph diagram. The swimmer is pushing up against the wall. Feet on the wall is greater than the direction of the acceleration. The wall is pushing back on the swimmer, wall on feet. The force exerted both on the swimmer and the wall are equal. 6.1, the conclusion. In conclusion, Newton's third law of motion For every action, there is an equal and opposite reaction. This is a fundamental principle of physics that continues to explain and predict the behavior of objects in motion. From launching rockets to walking, driving, and building structures, it remains a vital concept in science, engineering, and everyday life, highlighting the deep interconnection of forces in the natural world. Citations. More citations. Relevant sources and citations for information given. Thank you for listening.
Alright, my name is Kevin Avila, and today we're going to be talking about Newton's third law. Introduction. Newton's third law of motion states, for every action there's an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. These forces always occur in pairs and act on different objects. For example, when you push against the wall pushes back with an equal force. A rocket launches because the engines push gases downward, and the gases push the rockets upward. 2.2 Difficulties, complications explained. A major complication involved calibrating the motion and force sensors to ensure accurate synchronization. Small timing discrepancies initially caused mismatched force readings, making it appear as if the reaction force lagged. Additionally, ensuring a truly frictionless environment was challenging. Even minimal friction between the cart wheels and track caused slight discrepancies in observed accelerations. We addressed this by leveling the tracks precisely and using an air-cushioned track in later trials for more accurate results. 3.2 Differences in modern approach outline. Compared to classical experiments, the modern approach is more precise. Digital sensors reduce human error and allow for precise data collection. Broader in scope, the law is tested in environments ranging from outer space to subatomic particles. Data-driven, modern experiments emphasize data logging, statistical analysis, and repeatability. Incorporated into engineering, engineers use the third law in simulations before construction machines or vehicles, particularly in aerospace and robotics. 4.2 Benefits of understanding questions given. Understanding this question allows students to visualize how Newton's third law is even used in sports like swimming. Recognize how forces always come in a pair. Overall builds a foundation for more complex application. It also helps that the question builds a connection with most students because they have experience and can relate to being in a pool, pushing off the wall, and moving forward. 5.2 Relevant formulas and constants explained. Newton's third law is defined as, for every force, there's an equal force in the opposite direction. Newton's third law formula, F AB equals negative F BA. F being force, AB being object A applying force to object B, BA being object B applying the same amount of force back onto object A. Force is measured in newtons. Since the amount of force exerted on an object isn't always the same in this case, there is no constant. 6.2 Additional students' interests described. As all guys in our group, we naturally are interested in sports and activities. So without Isaac Newton, we would not be able to understand the true functionality of the sport and how they work.
Hey, I'm Corey Moore, and today I'm going to be going over the third minor objective. For every major objective for physics lecture, our topic is about Newton's third law of motion, so let's get right into it. So, this concept is very relevant in our everyday life. We can see it in transportation, cars, with the tires pushing backwards against the road, which is the action, and the road pushing forward on the car, which is the reaction. Planes, the jet engines expel air backwards and the planes move forward. And with rockets, the rockets expel exhaust gases downwards and the rocket moves upwards. This is critical for space travel, by the way. And as for sports, in swimming, a swimmer can push water backwards and the water pushes them forwards. And when a basketball player jumps, they push down on the floor and the floor pushes them upwards. 2.3. Motivation for experiment presented. Though Newton's third law is one of the first physics principles taught, many demonstrations are overly simplified and qualitative. Our motivation was to develop a more quantitative, high-precision investigation that could help students and researchers visualize and measure the law with modern tools. We aim to go beyond textbook illustrations by using sensors and data analysis to validate Newton's law under controlled and repeatable conditions. Section 3.3. Modern Benefits of Discovery Explained. Understanding and applying Newton's third law in a modern context has led to space travel advancements. Rocket propulsion systems rely directly on action-reaction principles. Improved transportation systems. Vehicle crash safety designs consider force pairs to reduce passenger injury. Biomechanics and prosthetics. Human motion studies apply the law to improve prosthetics and sports performance. Automation and robotics. Robots that interact with environments require force feedback systems grounded in Newton's third law. And we have a picture of a rocket, and when it takes off, obviously the exhaust gases blow downwards and the rocket goes up. Section 4.3. Process of writing question outlined. The question is constructed by a relatable scenario, which is swimming, the fact that it has two interacting objects, which is the swimmer and the wall, the value of the force, which is 120 newtons, and the reaction force, which is coming from the application of Newton's third law. This question will help us both understand Newton's third law and how to apply it. It helps us have a deeper understanding. And we also have a picture here of a girl pushing on the wall of a pool, and the wall pushes back on her with the amount of force that she exerted as well. Section 5.3. Solving process thoroughly described. The swimmer is pushing the wall with 120 newtons of force, and since Newton's third law of motion states that every action has an equal or opposite reaction, the wall is pushing back on the swimmer with 120 newtons of force as well. And we still have that same picture of the girl pushing on the wall, I told you last time, and here we have another representation of how the law works. Section 6.3. Overall summary of the topic presented. Newton's third law of motion is a cornerstone of physics, showing that forces always occur in equal and opposite pairs. It not only deepens our understanding of how motion and interactions work, but also plays a crucial role in the design and functioning of modern technology, transportation, and engineering. Its relevance proves that even old scientific principles remain essential to both everyday life and advanced scientific progress.
Hi, I'm Andrew Norris. I'm going to be doing all the point fours of each section. So we're going to start off with 1.4, relative scientist. Isaac Newton is the creator of this law of motion. He was born January 4th, 1643 in United Kingdom. He died March 31st, 1727 in the United Kingdom. When Isaac Newton created this law, it was revolutionary at this time for explaining physics and just everyday life. How it's implied, this law helps explain not just motion on Earth, but how planets and moons move. It became the foundation of modern physics, engineering, and space exploration. 2.4, the original benefits of discovery discussed. Our experimental setup confirmed Newton's third law with detailed numerical data showing that forces were indeed equal in magnitude and opposite in direction at all time during interactions. Beyond simply affirming the law, the experiment highlighted how each small external factor can affect real-world implications of physical law. This can be particularly useful in engineering fields where time, precision, and force balances are critical. The setup we created also as an educational tool, offering a hands-on tech integrated way to teach classical mechanics. 3.4, future expectations of research discussed. Looking forward, Newton's third law continued to be a foundation for innovation. Future research is expected to be advanced propulsion technologies, exploring quantum action-reaction relationships, enhanced human-robot interaction, aid in space exploration. 4.4 Uniqueness of question discussed. The uniqueness of the question. It's a familiar and a physically felt experience. Yeah. It's a combination of qualitative understanding and qualitative answer. Unlike textbook questions, this question invites the student to connect theory and motion when they're experimenting themselves. 5.4 Solution correct / applied to topic. The solution is that the wall is pushed back 120 newtons of force. This works because force always comes in pairs. A swimmer is going forward because of the wall's push. This is real life proof in Newton's third law. We rely on this to walk, swim, move, do everything in our lives. Overall summary of the topic presented. Newton's third law of motion is a cornerstone of physics, showing that force always occurs in equal and opposite pairs. It is not only deepens our understanding on how motion and interactions work, but also plays a crucial role in the design and functionality of modern technology, transportation, and engineering. Its relevance provides the old scientific principles remaining essential to both everyday life and advanced scientific progress.